1.5 billion kilometers from the Sun, majestically orbiting Saturn, lies a moon that defies all expectations. Titan is not just another rocky satellite silently wandering through the cosmos. It is a world unto itself, so large that it surpasses even Mercury, that small planet that orbits so close to our Sun. Think about that for a moment. A moon, a satellite of another planet, larger than an entire planet in our system. It's as if nature decided to create something extraordinary in the cold outer regions of our cosmic home. But Titan's size is only the beginning of its uniqueness. Among all the moons we know, and there are hundreds orbiting the planets of the solar system, Titan is the only one that possesses a dense, thick, enveloping atmosphere. Not a thin layer of gases slowly escaping into space, but a true atmospheric blanket, thicker even than our own Earth's atmosphere. It's as if Titan were a small planet disguised as a moon, hiding secrets beneath its eternal clouds. And when we analyze this atmosphere, we find something surprisingly familiar. It is composed primarily of nitrogen, just like the air you are breathing right now as you rest comfortably. It is the same element that makes up about 78% of our atmosphere. An unexpected chemical connection between this distant world and our blue home. But Titan holds its greatest surprise when we look at its surface. There, beneath those hazy orange skies, lie real seas and lakes. Not seas of water like our oceans, but vast expanses of liquid shimmering in the faint, distant light of the sun. These seas are composed of methane and ethane, hydrocarbons that on Earth we know only as gases, but which remain liquid in Titan's frigid temperatures, filling basins and depressions like water fills our oceans. And these aren't just stagnant puddles. Some of these seas are so large, so deep, that they have waves moving across their surfaces. There are tides caused by Saturn's gravity pulling and pushing these liquid masses. There are currents flowing through them, creating complex circulation patterns. It's a complete hydrological cycle, but instead of water, it's a methane cycle. Completely alien, yet strangely familiar in its structure. Titan has rain falling from its thick clouds. It has rivers snaking through its landscape, carving valleys and channels. There are clouds forming and dissipating, weather systems moving through the atmosphere. There is erosion slowly shaping the surface features. It is a meteorologically active, dynamic, living world in a way. But all this happens with hydrocarbons instead of water. It's as if nature created an alternate version of Earth, using completely different materials, but following the same fundamental physical laws. The average temperature on Titan's surface is 179 degrees Celsius below zero. It's so intensely cold that water, that substance that flows liquid and warm in our rivers, freezes solid like granite. On this icy world, water ice doesn't melt, it doesn't flow. It behaves like rock, hard and permanent, forming mountains, cliffs, the very ground beneath the feet of a visiting probe. The soil of Titan is composed of this ice, as hard as stone. It's an alien surface where stepping on it would be like walking on terrestrial rock, but chemically it would be like walking on frozen water. The distinction between what is ice and what is rock loses meaning in this distant world. And across this icy landscape stretch gigantic dunes, some hundreds of kilometers long. They spread in undulating patterns across vast plains, shaped by winds blowing through the dense atmosphere. But these dunes are not made of quartz sand like terrestrial dunes. They are composed of dark organic grains, complex particles formed by chemical reactions in the upper atmosphere, slowly falling like chemical snow over millennia. They are organic molecules, the building blocks of life, accumulating in massive deposits. When you look at the sky of Titan, if you could be there, protected from the deadly cold, you would see something profoundly strange. The sky is not blue like ours, nor black like the moon's. It is permanently orange, tinged by a thick haze of organic particles suspended in the upper atmosphere. It's like being perpetually inside a misty sunset, with diffuse light coming from all directions, but never managing to see the distant sun directly through the mist. And the surface is so dark, so obscured by this thick atmosphere, that even with advanced instruments it's difficult to see more than a few meters ahead. It's a world of eternal twilight, where the sunlight that reaches it is 1,000 times weaker than the light that bathes the earth. It would be like living in a perpetual twilight, where shapes are only vaguely visible, where outlines dissolve into the orange haze. But humanity wasn't content to merely observe Titan from afar. In 2005, the Cassini mission, after years traveling through the solar system, released a small probe called Huygens. This robotic capsule descended slowly through Titan's dense atmosphere, parachutes deployed, instruments recording every second of the descent. For more than 2 hours it fell, traversing layers of clouds, measuring winds, temperature, and chemical composition. And finally, gently, it landed. The images Huygens sent back showed a landscape that somehow looked familiar. It was a frozen desert, a plain dotted with rounded pebbles scattered as if left by an ancient riverbed, and they probably were. Scientists believe these stones were shaped, smoothed, and rounded by rivers of liquid methane that flowed through this region at some point in Titan's distant past. It's liquid erosion, working in the same way our terrestrial rivers work, but using a completely different solvent. Titan's gravity is incredibly weak. Only 14% of the gravity you feel right now, gently pressing you against your mattress. In this world of low gravity and dense atmosphere, something magical would be possible. A human, properly protected from the cold, of course, could literally put wings on their back and fly using the power of their own muscles. The combination of dense air to push against and weak gravity to overcome would make human flight not only possible, but relatively easy. It would be like fulfilling Leonardo da Vinci's age-old dream, gliding through the orange skies of an alien world. But Titan's surprises don't end on its surface. Deep beneath that icy crust, under kilometers of rock-solid water ice, scientists suspect there is a vast ocean of liquid water. It would be similar to the subsurface ocean we believe exists beneath the ice of Europa, that moon of Jupiter. On Titan, this ocean would be squeezed between layers of ice, perhaps heated by internal heat remaining from the moon's formation, or by tidal forces generated by Saturn's gravity. If this ocean truly exists, and gravitational evidence strongly suggests that it does, then it could represent something extraordinary. Liquid water, isolated from the vacuum of space, heated enough to remain liquid, perhaps containing dissolved minerals from the rocky core below. These are the conditions that, on Earth, allowed life to emerge. Could there be alien microbial life swimming in these dark, deep waters? Organisms that have never seen the sun, that evolved in complete isolation from the universe above. It is because of these fascinating possibilities that Titan is considered one of the most promising places in the solar system to find life. Not just life, but two potentially habitable environments on a single world. The methane seas on the surface, where life forms based on exotic chemistry could exist, and the ocean of water underground, where life more familiar to us could thrive. It is a natural astrobiology laboratory, a place where nature may have conducted two completely different life experiments, one on top of the other. Breathe gently. Let your mind wander through the orange skies of Titan. There is so much more to discover about this extraordinary world. Let's return to those seas of methane and ethane, those liquid expanses that shimmer beneath the hazy skies of Titan. They are truly unique in the entire solar system, the only place besides Earth where we find stable bodies of liquid on the surface of a world. And these seas are not tranquil and still. They have real waves moving across their surfaces, pushed by winds blowing through the dense atmosphere. Depending on the season on Titan, which lasts more than 7 Earth years, since Saturn takes almost 30 years to complete an orbit around the Sun, these waves can reach up to a meter in height. Imagine waves of liquid methane crashing against beaches of water ice under a rust-colored sky. The largest of these seas has an appropriately mythical name, Kraken Mare, named after the legendary sea monster of Norse tales, and it lives up to its name with its impressive size. Kraken Mare is larger than the Caspian Sea, that vast body of water between Europe and Asia. It is so extensive that if you were on one of its shores, the other shore would be beyond the horizon, invisible through the orange haze. Scientists estimate that this alien sea may have depths exceeding 300 meters in some regions, deep enough to swallow entire skyscrapers if we could somehow transport them to that distant world. Titan's surface is sculpted and shaped by processes that seem strangely familiar to us. Methane rain falls from thick clouds, accumulates in streams, flows into rivers, carves deep valleys, creates complex deltas where rivers meet the seas. It is liquid geology in action, the same erosive processes that shaped Earth over billions of years, but executed with a completely different chemistry. These rivers would meander through icy plains, their banks defined not by clay and sedimentary rock, but by water ice as hard as concrete, smoothly polished by the flow of liquid hydrocarbons. The landscapes created by these processes are strikingly similar to terrestrial ones when viewed from above. Dendritic networks of channels converging into larger arteries, meanders snaking through plains, fan-shaped deltas where rivers deposit sediments as they meet seas. If you saw these formations in a photograph without context, you could easily mistake them for terrestrial features. But the underlying chemistry is completely alien. Liquids that on Earth are fuels, sculpting rocks that on Earth are ice, and that cold, an average of 179 degrees Celsius below zero. It's so profoundly cold that even nitrogen, the gas that makes up most of our atmosphere, is dangerously close to liquefying. At these temperatures, chemical processes that take seconds on Earth can take centuries. Molecules move in slow motion. Reactions happen with glacial slowness. It's a world frozen in time, where change occurs, but on timescales that defy our comprehension. When snow falls on Titan, and it does fall, floating gently through the dense atmosphere, it's not the fluffy white snow we know. It's dark, almost black, composed of complex organic molecules that formed in the upper atmosphere through photochemical reactions driven by faint sunlight. These dark particles accumulate slowly, layer upon layer over eons, creating deposits that are eventually sculpted by the wind into dunes, or washed by methane rain toward the seas. Titan's atmosphere is so incredibly thick, so dense compared to its weak gravity, that it creates surprising possibilities. If you could be there, protected of course in a suit kept warm against the deadly cold, and if you had a pair of artificial wings attached to your arms, you could literally flap those arms and glide through the air. The air resistance would be sufficient, the gravity weak enough, that human muscular flight would not only be possible, but relatively easy. It would be like swimming through dense air, propelling yourself upward and forward with each beat. The ancient dream of Icarus, achievable on a world 1.5 billion kilometers from home. Titan possesses an extraordinary distinction among all the worlds we know. It is the only place, besides Earth, where we observe an active hydrological cycle, or more precisely, a methane cycle. Evaporation from seas and lakes, condensation into clouds, precipitation as rain, flow through rivers, return to the seas. It is the same cycle that moves water on Earth, but on Titan it moves methane. It's as if nature created a parallel version of our planet, using a different chemical blueprint, but following the same fundamental physical rules. And when this rain falls, it doesn't fall quickly like terrestrial storms. Due to the low gravity and resistance of the thick atmosphere, the methane droplets fall slowly, almost like a liquid mist gently descending. It would be like being inside a very humid cloud, with tiny droplets condensing in the air around you and lazily falling towards the ground. A rain you could calmly observe, watching each drop in its slow descent. That characteristic orange sky, so different from Earth's blue or the moon's black, is not colored by the light of the distant sun. It is tinged by organic aerosols, microscopic particles of complex molecules suspended in the upper atmosphere. They are like permanent chemical smoke, created by the breakdown of methane by solar ultraviolet radiation, recombining into increasingly longer and more complex chains of hydrocarbons. These particles remain suspended for years, perhaps decades, absorbing blue light and letting through mainly orange and red tones, painting the entire sky with that deep Martian color. And the sunlight that finally manages to penetrate this thick haze takes more than an hour to travel from the top of the atmosphere to the surface. It is scattered, refracted, absorbed, and re-emitted countless times on its downward journey. When it finally reaches the ground, it is a diffuse light, coming from all directions at once, without sharp shadows, without strong contrast. The sun itself is almost invisible from the surface, just a blurry, bright spot somewhere in the orange sky, its defined shape obscured by the omnipresent haze. But Titan's wonders aren't limited to its exotic surface. Deep beneath that icy crust, perhaps 50 or 100 kilometers below, lies a subsurface ocean that may contain more water than all of Earth's oceans combined. Think of the scale of that. Every drop of water in all of Earth's seas, in every river, in every lake, and even more water hidden in the dark depths of Titan. It's a global ocean, shrouded in ice, isolated from the universe above, existing in absolute silence for billions of years. And this ocean isn't just pure water. Evidence suggests it may be salty, perhaps enriched with ammonia, that compound we know on Earth as a pungent household cleaner. Ammonia acts as anti-freeze, lowering the freezing point of water, allowing the ocean to remain liquid at temperatures where pure water would solidify. This salty, ammoniacal ocean, heated perhaps by residual internal heat or tidal forces, may have persisted in a liquid state since Titan's formation more than 4 billion years ago. It is because of these extraordinary characteristics that many scientists consider Titan one of the best, if not the best, candidates for harboring microbial life in the solar system. Not just one habitable environment, but two completely different ones: the methane seas on the surface, where life would have to use exotic chemistry, perhaps replacing water with methane as a solvent, and the ocean of water underground, where life forms more familiar to us could exist. The possibility of methane-based life on the surface is particularly intriguing. On Earth, all life uses water as its fundamental solvent. But on Titan, with its seas of liquid methane, could life have found a way to use hydrocarbons instead? Would organisms be operating in super slow motion due to the extreme cold, metabolizing hydrogen instead of oxygen, building cell membranes from completely different materials? It would be life, Jim, but not as we know it. Genuinely alien, not just in origin, but in fundamental chemistry. Titan's giant dunes, the ones we mentioned earlier, aren't made of quartz like terrestrial dunes. They're composed of dark grains of solid hydrocarbons, complex organic molecules that have fallen from the atmosphere over eons. Imagine standing atop one of these dunes, looking around. You'd see a landscape that somehow seems familiar. Undulations of granular material stretching to the horizon, but rendered in dark, almost black tones. The sky above would be a deep orange, almost red at the edges. The light would be dim, diffuse, without sharp shadows. It would be like being inside an alien dream, a landscape simultaneously familiar and profoundly strange. Close your eyes gently. Visualize that dark desert under an orange sky. Feel the weak gravity, the dense air. There are still more mysteries waiting in the misty depths of Titan. That extreme cold of 179 degrees Celsius below zero is not just a technical detail. It's the fundamental force that makes Titan unique. At that extraordinary temperature, substances that on Earth are merely invisible gases become dense liquids, capable of filling basins and forming oceans. Methane, that odorless gas we use as fuel on Earth, becomes a thick liquid, flowing through channels, accumulating in depressions, behaving exactly like water behaves in our temperate world. And let's return to that magical possibility. Titan's gravity is so gentle, so weak, only a fraction of the force that keeps you pressed against your bed right now. Combine that with that incredibly dense atmosphere, and something extraordinary becomes possible. A human being, with artificial wings attached to their arms and back, could genuinely fly under their own power. Not passive gliding, but active muscular flight. Flapping wings, gaining altitude, spinning through that orange sky. It would be like fulfilling humanity's oldest dream, but on a world so distant that Earth would be just a pale blue dot lost in the glare of Saturn. Titan holds that singular distinction among all the worlds we've explored, the only place beyond our home where stable lakes exist on the surface. But when we descend to examine these lakes more closely, we discover that any comparison to Earth ends there. There is no water in these lakes, no liquid H2O molecules shimmering in the sun. Instead, it is methane and ethane, liquid hydrocarbons filling these basins, reflecting the faint orange light that manages to penetrate the atmospheric hazes. And Kraken Mare, that vast alien sea we've already mentioned, deserves to be contemplated more deeply. It's so extensive that from one shore you couldn't see the other, even if the sky were clear. Titan's curvature would take the opposite shore beyond the horizon, 300 meters deep, perhaps more in its deepest trenches. It's deep enough to swallow cathedrals, to hide skyscraper-sized structures in its icy methane depths. What strange creatures might swim in those depths if life found a way to exist there? Organisms that breathe hydrogen instead of oxygen, built of chemistry that defies everything we know about biology. Now imagine something surprising. If you could travel to Titan, you wouldn't need a full pressurized suit like astronauts wear on the Moon or Mars. The atmosphere is so dense, so thick, that it provides adequate pressure for your body. You would only need intense heating to survive the deadly cold, and an oxygen mask, of course, since there is no breathable oxygen in that nitrogen-rich air. But you could walk on the surface wearing something more like a heated diving suit than a bulky spacesuit. It would be a strange sensation, the dense air resisting every movement, like walking underwater, but without the buoyancy. That air is composed primarily of nitrogen, the same dominant gas you're breathing right now, but mixed in with it is a persistent haze of hydrocarbons, methane molecules broken down by sunlight and recombined into longer chains, creating a chemical fog that permeates the entire atmosphere. This haze acts as a natural sunscreen, absorbing blue light and letting through orange and red hues, permanently tinting the sky with that characteristic rust color. Titan's surface exists in eternal twilight. Even at local noon, when the sun, as seen from the surface, would be at its highest point in that blurred patch of sky, the illumination would resemble a late terrestrial sunset. It would be like living within the perpetual golden hour that photographers adore, but stretched indefinitely, without the promise of dawn or the certainty of dusk. Just this diffuse orange light, coming from all directions at once. When rain falls from those thick clouds, it falls with an almost surreal slowness. The combination of low gravity and high atmospheric resistance causes each drop to descend in slow motion. A single drop of liquid methane can take hours on its journey from the clouds to the ground, floating gently through the dense air. You could watch a storm approaching and have enough time to seek shelter before the first drop reaches you. And these drops aren't water. They're liquid methane, cold enough to instantly freeze any form of terrestrial life that touches them. When the Huygens probe landed in 2005, it sent back fascinating images of the surface. Among the features it recorded were rounded stones, pebbles with smoothed edges scattered across the landscape. On Earth, such stones are polished by flowing water over long periods. On Titan, the erosive agent was liquid methane, flowing through ancient rivers, rolling these stones, made of water ice as hard as granite, along riverbeds, smoothing their edges through countless collisions over eons. The giant dunes that snake across vast equatorial regions of Titan are monuments to the strangeness of that world. They are not made of quartz, that resilient mineral that forms most terrestrial sands. Instead, they are composed of dark organic grains, complex hydrocarbon molecules synthesized in the upper atmosphere through photochemical reactions. These particles fall slowly like chemical snow, accumulate over millions of years, and are shaped into dunes by the persistent winds that blow through the dense atmosphere. Some of these dunes reach 100 meters in height, structures as tall as 30-story buildings, sculpted not from terrestrial sand, but from alien sand, organic material that under slightly different conditions could have become the building blocks of life. They stretch for hundreds of kilometers, creating landscapes reminiscent of terrestrial deserts, but rendered in dark shades of brown and black under that eternally orange sky. And once again, we return to that hidden ocean, that massive body of liquid water trapped beneath kilometers of icy crust. It may contain more water than all of Earth's oceans combined: the Pacific, the Atlantic, the Indian, all the seas, all the lakes, all the rivers, and even more. It's difficult to comprehend the scale of it. A global ocean, shrouded in ice, never touched by sunlight, existing in intense darkness and pressure, isolated from the universe by a crust of water ice that is, at those temperatures, as hard as basalt. The pressure beneath this icy crust is immense, crushing, and some scientists speculate that this pressure, combined with internal heat, whether from Titan's rocky core or from tidal forces generated by Saturn's gravity, could create something extraordinary: cryovolcanism, ice volcanoes. Imagine that. Instead of molten rock lava, these volcanoes would spew water and ammonia, perhaps mixed with methane. Icy eruptions piercing the crust, launching geysers of liquid water that would instantly freeze upon contact with the ultra-cold surface. Some scientists believe they have identified features on Titan's surface that could be ancient cryovolcanoes, places where liquid water from the deep ocean once briefly reached the surface. It is because of all these extraordinary characteristics, the rich organic chemistry, the multiple potentially habitable environments, the complex liquid cycles, that some scientists consider Titan the best chance of finding primitive life in the solar system, after Earth itself. Not complex life, certainly, but perhaps microorganisms, alien bacteria adapted to the extreme cold, metabolizing through exotic chemistry. And there's a particular reason why Titan is so intriguing in this quest. Its chemistry, rich in organic compounds, may be similar to that of early Earth, about 4 billion years ago, before life emerged here. Titan may be like a chemical time machine, showing us conditions similar to those that existed on our own planet before the first living organisms emerged from the primordial seas. Studying Titan is, in a way, studying our own distant past, preserved on a frozen world 1.5 billion kilometers away. Let's return to that enchanting possibility that seems to arise repeatedly when we contemplate Titan. Gravity is so gentle, so weak, only 1/7 of the force you feel now, that with surprisingly light, almost minimalist equipment, a human could genuinely fly. No elaborate jetpack or powerful engines would be needed. Just wings attached to the arms, perhaps a light support structure, and you could flap those arms and soar through that dense orange air. It would be like swimming through the sky, pushing against an atmosphere that offers enough resistance to support you, but gravity weak enough that your muscles can overcome it. It would be pure human flight, finally achieved, but in a world so distant we can scarcely imagine it. The dunes that cover vast equatorial regions of Titan deserve deeper contemplation. They are not formed of mineral grains like our terrestrial dunes. They are composed of complex organic particles, molecules derived from the breakdown and recombination of methane and ethane in the upper atmosphere. They are the products of a slow and constant chemistry occurring in the upper layers of Titan's atmosphere. Ultraviolet sunlight breaking down simple molecules, which then recombine into increasingly complex forms, eventually becoming heavy enough to fall, accumulating over eons into massive deposits. These dunes stretch for thousands of kilometers, creating alien deserts on a scale difficult to comprehend. and they are dark, almost black, absorbing the little light that manages to penetrate the hazy atmosphere. Imagine standing atop one of these dunes. The ground beneath your feet would be black and granular, stretching in all directions until it disappears into the orange haze. It would be a midnight desert under a sunset sky, a surreal inversion of everything we know about desert landscapes. And these dunes are not static. Titan's winds change direction as the seasons progress. And remember, a single season on Titan lasts more than 7 Earth years. As these persistent winds shift, the dunes are slowly reshaped, grain by grain, over decades. It's as if the entire satellite slowly breathes, inhaling and exhaling through cycles spanning human generations. Planetary scientists, fascinated by Titan's meteorological complexity, began calling it frozen Earth in slow motion. It's a perfect description. All the processes we see on Earth, evaporation, precipitation, erosion, sedimentary deposition, happen on Titan, but executed with different chemistry and on timescales radically altered by the extreme cold. It's like watching a movie of Earth playing in slow motion, each process familiar but strangely slowed down. The storms that occasionally sweep across Titan can last for months. The atmosphere is so dense, containing so much thermal energy even at those frigid temperatures, that once a weather system forms, it persists with extraordinary tenacity. Thick clouds of condensed methane can blanket continent-sized regions for weeks on end, slowly releasing their load in the form of persistent rain. And that rain, we've already mentioned its slowness, but it's worth contemplating again. A single drop can take minutes to descend from the low clouds to the ground. You could literally watch individual drops floating gently through the dense air, falling in super slow motion as if immersed in transparent honey. It would be hypnotic, meditative, to watch a storm approach on Titan. In certain regions, especially during the wetter seasons, rainfall can be surprisingly intense. Rivers of methane swell and overflow, carving deeper valleys, dragging ice sediments and organic material, depositing them in new patterns. Over millions of years, these periodic rains completely reshape the landscape, creating and destroying geological features in a slow but relentless cycle. Interestingly, Titan has pronounced hemispheric asymmetry. The lakes and seas of the northern hemisphere are significantly larger and more numerous than those of the southern hemisphere. It's as if Titan has a wet side and a dry side, an uneven distribution of its liquid resources. Scientists still debate why this asymmetry exists. It may be related to subtle differences in topography, or perhaps to long-term climatic cycles that gradually move methane from one hemisphere to the other over millennia. Kraken Mare, that vast sea we've mentally visited many times, is deep enough for terrestrial submarines to explore its icy depths. Imagine a submarine designed for that environment, not to withstand the crushing pressure of the deep oceans, but to operate on liquid methane at 180 degrees Celsius. What wonders could be discovered in those dark depths? What chemical processes might be occurring at the bottom of those seas, where liquid methane meets the icy ocean floor? The temperature of these seas varies slightly with the seasons, and with the exact composition of the methane-ethane mixture. Some are slightly warmer at 180 degrees Celsius, others drop to 190 degrees Celsius. These variations may seem trivial, but in a world where a few degrees can mean the difference between liquid and solid, these fluctuations are significant. Some smaller lakes exhibit even stranger behavior. They seem to disappear and reappear seasonally. During colder seasons, methane can freeze completely, transforming a liquid lake into a solid surface of methane ice. Then, when temperatures rise a few degrees during warmer seasons, this ice sublimates or melts, and the lake reappears. They are ghost lakes, existing on a delicate threshold between physical states. There are regions on Titan's surface where the soil is surprisingly soft, a peculiar mixture of water ice, sticky organic mud, and semi-frozen hydrocarbons. Future probes landing in these regions could partially sink, like landing on quicksand. It would be like stepping into a frozen swamp, where each step sinks a few centimeters into a substrate that is neither completely solid nor entirely liquid. Titan's surface is not geologically dead. There are tectonic faults, fractures in the crust, suggesting that the interior is still active in some way. Perhaps the rocky core at the center of Titan still retains heat from its formation billions of years ago. Perhaps tidal forces, generated by Saturn's gravity pulling and pushing as Titan orbits, generate heat through internal friction. In any case, there is movement happening beneath that icy crust. The entire surface can subtly expand and contract as the crust responds to Saturn's tidal forces. As Titan moves through its slightly elliptical orbit, the gravitational force it experiences varies slightly. This causes the crust to flex, creating stress that eventually manifests as fractures and faults. It's as if Titan were a rubber ball being gently squeezed and released repeatedly, elastically deforming in response to external forces. And then there are those possible ice volcanoes we mentioned earlier. Structures that may have expelled not lava from molten rock, but liquid water mixed with ammonia and methane. These cryovolcanic eruptions would have been extraordinary events. Geysers of water gushing through the icy crust, freezing instantly upon contact with the ultra-cold atmosphere, building mountains of ice layer upon layer through countless eruptions. Some scientists speculate that some of these cryovolcanoes may still be active, slowly renewing specific regions of the surface in cycles spanning centuries or millennia. It would be fascinating to witness. An eruption happening not in explosive seconds, but unfolding over months or years. Liquid water from the deep ocean briefly reaching the surface before freezing and sealing the opening again. Titan's appearance changes over time when viewed from a distance. The organic haze that permeates its atmosphere thickens or thins as solar radiation varies with the seasons and long-term solar cycles. During some decades, Titan may appear more orange, more opaque. In other eras, the haze may thin slightly, making the surface a little more visible through the atmospheric layers. That characteristic orange color, that deep hue that defines Titan's sky, is created by specific molecules called tholins. It's a term coined by astronomer Carl Sagan to describe these complex organic molecules formed when ultraviolet sunlight breaks down methane and nitrogen in the upper atmosphere, allowing them to recombine into increasingly elaborate forms. These tholin molecules are responsible for the persistent haze, the orange color, and the obscurity of the surface. And here's something truly fascinating. These same tholins may have been fundamental ingredients in the beginnings of life on Earth billions of years ago. Our own early atmosphere may have produced similar compounds, raining them down on primordial oceans where they eventually organized into increasingly complex forms, eventually crossing the hazy threshold between chemistry and biology. And Titan produces them in gigantic quantities, billions of tons over eons, accumulating them on the surface in the seas, perhaps even in the subsurface ocean. It's a prebiotic chemistry factory operating on a planetary scale, preserved in deep freeze, waiting to be studied. Let these images float gently in your mind. Dark dunes, seas of methane, orange skies of tholins. There is one last journey through this extraordinary world. Titan's dunes hold a remarkable record. They are the longest in the entire solar system. They stretch for hundreds of kilometers, snaking across equatorial plains like frozen rivers of dark sand. But they are not sand in the sense we know it. Each grain is composed of complex organic molecules, end products of a slow and steady atmospheric chemistry. Methane broken down by sunlight, recombined into increasingly elaborate forms, eventually becoming heavy enough to fall as dark chemical snow, accumulating over geological eras. When storms sweep through these regions, they can persist for months. Atmospheric circulation on Titan is surprisingly slow, despite the air density. Weather systems, once formed, take weeks or months to move from one region to another. It's slow-motion meteorology, cloud patterns evolving with a patience that defies our terrestrial experience of rapid climate change. And then there are those possible cryovolcanoes, alien volcanic structures that, if confirmed, would revolutionize our understanding of Titan. Instead of spewing incandescent molten rock, these volcanoes would erupt liquid water mixed with ammonia, perhaps with dissolved methane. This ice lava would flow briefly before freezing solid, building mountains and cones layer by layer over countless eruptions spaced centuries or millennia apart. If these cryovolcanoes truly exist and are active, Titan would have something truly extraordinary. A complete hydrogeological cycle. Liquid water emerging from the depths, freezing on the surface, being gradually buried by organic sediments, eventually being carried back to the depths by tectonic processes, reheated and erupting again. It would be like Earth's water cycle, but running in ice, happening over geological timescales. There's an intriguing detail that fascinates astrobiologists. Titan receives approximately the same amount of solar radiation that Mars received billions of years ago, when that red planet was warmer, wetter, and potentially habitable. It's as if Titan were a frozen analog of young Mars, preserved in cryogenic amber, offering us a window into conditions that may have allowed life on another world in the distant past. Certain regions of Titan's surface resemble frozen swamps, terrains where water ice, sticky organic material, and semi-frozen hydrocarbons mix in a complex matrix. It would be like walking through a terrestrial swamp, but at a temperature so low that each step would crack and creak, breaking ice crystals, sinking slightly into material that is simultaneously solid and semi-fluid. If any future explorer were to remove their helmet, not that this would be advisable, the smell of Titan would be unforgettable and probably unpleasant. It would be similar to gasoline mixed with burnt plastic, that acrid odor of complex hydrocarbons that on Earth we associate with refineries and industrial processes. It is the smell of uncontrolled organic chemistry, happening on a planetary scale without the moderating presence of life and oxygen. And Titan's sky, which we described as orange, actually has subtle gradations of color. Near the horizon, where you look through a thicker atmospheric layer, the hues shift to deep pink, almost red. It's like a perpetual sunset in every direction, with colors ranging from intense orange at the zenith to pinks and reds near the horizon. It would be visually stunning once your eyes adjusted to the dim light. Because the light is really dim, even at local midday under that thick orange haze, the illumination would be equivalent to a dark late afternoon on Earth, perhaps minutes before the sun completely disappeared below the horizon. It's an eternal twilight light, suitable for dreaming and contemplation, but challenging for any activity requiring clear vision. The surface temperature is so brutally cold that processes that take minutes or hours on Earth happen in seconds. Wet methane, if you could somehow have wet methane, would freeze in seconds upon exposure to the surface. Ice crystals would form instantly, turning liquid into solid almost on contact. If you were to walk across the surface of Titan, you could walk for hours without leaving a perceptible trace. In many regions, the surface is extremely smooth, almost polished, composed of finely divided material that doesn't retain impressions. It would be like walking on fresh, flawlessly smooth snow, except that this snow is dark organic material, and you would be walking through a frozen world under an alien sky. Meteor impacts are surprisingly rare on Titan. That dense, thick atmosphere acts as an extraordinary protective shield. Objects that on the Moon or Mars would create significant craters are slowed down, heated by friction, and often completely destroyed before reaching the surface. It's like having a natural atmospheric shield, protecting the surface from cosmic bombardment. Titan is one of the very few moons that exhibits genuine, active erosion. Wind sculpts dunes, rain carves valleys, lakes wash and erode shorelines. It is a geologically living world in a sense that most moons are not. Earth's moon, for example, has been geologically dead for billions of years, its surface changing only through occasional impacts. Titan changes constantly, slowly, through active surface processes. And then there are those magic islands, mysterious features observed in some lakes. Islands that appear, disappear, and reappear in slightly different places. Scientists speculate that they may be caused by bubbles of nitrogen or methane forming at the bottom of the lakes, slowly rising, accumulating beneath the liquid surface until they become large enough to be detected by radar. Then the bubble bursts or dissipates, and the island disappears. It's ephemeral geology, temporary features in a world where even the permanent is slowly changing. That subsurface ocean we've mentioned repeatedly may be extraordinarily salty. NASA suspects, based on subtle gravitational measurements, that it may be as salty as the Dead Sea. That hypersaline body of water on Earth where nothing can sink due to its extreme density. An ocean of salt water, perhaps enriched with ammonia, isolated beneath kilometers of ice, existing in absolute darkness for billions of years. What strange adaptations would life need to develop to thrive there? Because if there is life on Titan, it would be fundamentally different from anything we know. Perhaps not based on water as a solvent, but using liquid methane. Cell membranes made of materials that remain flexible at 180 degrees Celsius. Metabolism operating in super slow motion, perhaps taking years to execute processes that on Earth take seconds. Biochemistry that breaks all the rules we've learned studying terrestrial life. It would be life, but not as we know it. Genuinely alien in its fundamental chemical essence. Polar regions exhibit extreme seasonal behavior. During the polar winter, which lasts more than 7 Earth years, lakes can evaporate completely. The methane sublimating or freezing, leaving behind empty basins. Then, when summer finally arrives, rains return, rivers flow again, and the lakes are replenished. They are ghost lakes, existing and ceasing to exist in cycles spanning Earth decades. and perhaps more important than any individual characteristic. Titan is rapidly becoming the priority scientific destination for the next generations of space exploration. Missions are being planned. A drone called Dragonfly, programmed to fly through Titan's atmosphere, land at multiple locations, analyze surface chemistry in search of signs of life or prebiotic chemistry. It is considered by many scientists to be the most promising place to find completely alien life in the solar system. Not life like ours, but something fundamentally different, adapted to conditions that seem impossible for terrestrial organisms. Good night, sleep well, dream of distant worlds shrouded in orange mists, where rain falls slowly and alien oceans await exploration.